Hello and welcome to our video for IoT on blockchain. I'm Stacy Schneider and I have with me Pad Kankipati. We're both from Provide Services. We are a blockchain platform company and we've had a number of customers looking to hook up IoT devices to the blockchain and thought that we would show you guys how easy this all can be. It makes sense that these things go together. We've got a distributed Internet of Things, and then we've got a distributed ledger technologies. These two distributed topics can mesh together in order to build a nice solution for your IoT needs, and it adds a layer of security to it as well. In our use case today, we are going to have a very simple use case, just monitoring and tracking a package throughout the shipment. We're going to go and collect a couple different heuristics, including temperature and humidity, location, and then we have an accelerometer on there in order to monitor sudden drops. Our solution is comprised of some hardware devices. We chose the Particle I/O Electron device. It is probably not the device that we're going to roll out in production with our customers, but we have found that it is a really cool device in order to be able to solder and pull together whatever kind of device we want in order to model the behavior that we want. So it's really good for our proofs of concepts. It is, of course, good for production as well. However, the cost of it is a little on the high side for some of our customers' use cases so far. And then, of course, we're going to be building this on the Provide platform, which provides you a lot of economies of scale, and it helps to build your proofs of concepts out incredibly fast. And then finally, we're going to build a reader application, which is going to show how all of our hardware has been tracked onto the blockchain, and we're going to use Google Maps running on a Node.js app. A little bit more about this Particle I/O Electron device. There's a number of different devices that they have out there. We particularly chose the Electron device. It supports 3G. By the end of 2019, they're going to be phasing out 2G. So we didn't want to go use the cheaper 2G devices. We really wanted to go focus on 3G LTE or higher. We also needed to make sure that it was programmable so that we could actually go right onto the device itself and custom collect only the information that we wanted to collect into our systems. Again, this device starts at $69. I think we actually ended up spending about $100 when we added a couple of the other configurable components on there. So you can go to their site and take a look at it. These are great devices for POCs and building things out. The Provide platform is a great platform for blockchain development. It cuts out a lot of the heavy lifting. We have customers that tell us it used to take them 6 days to stand up their blockchain distributed applications or dApps, and they say that they can do it in under 6 minutes with us. So that's 100 times or more faster development times, and it dramatically lowers the cost. Basically, we take out the heavy lifting of all the ABI that you need to know and maintain and do, and we just do it for you for free. So your developers get a massive boost in productivity. So it really accelerates your proofs of concept and lowers your overall cost of ownership of your end solution. Provide's also got a couple other advantages. One, we are chain and protocol agnostic. So while we built this particular solution in Ethereum, you would have the choice of building it in Quorum or Bitcoin or Bcoin or other protocols as well. And we're open to be able to be adding on to our platform over time. We also have, importantly, programmable REST APIs. So you go and develop your code, and then we give you the APIs for free, which is an amazing boost to productivity. And these little code snippets allow you to quickly leverage what you've built on the blockchain into other applications. And we're going to show that in action here tonight. And then, of course, the automated blockchain orchestration, which allows you to basically have your full deployment and scalability capabilities built in for free. So we're able to scale to 1 million transactions per second without you having to do anything more than press go. Finally, we chose to use Google Maps as the basis of our reader application. It's a pretty easy choice there. They cover 99% of the world. They got 1 billion monthly active users. The whole world's on Google Maps. So it was just a really easy choice for us to use. Certainly there are others out there, but this one seems to make the most sense. So without further ado, I want to turn this over to Pad. So Pad, can you explain a little bit more about how these things all work together and
Sure.
what we used?
Thank you, Stacy. We will go into 3 parts of it. Part 1 would be how the code is set up on the hardware side of it, which is the C++ code, and also we used, as we talked earlier, we used a particle IO Electron module, which has an INO feature. And an INO is nothing but a loop code that goes and reads the data from the individual sensors and transmits that data to the particles publishing system. In addition to that, after that we will go into our Solidity contract. The Solidity contract is what shows how this data gets into the blockchain, which shows all the humidity feature, the key components, which is temperature, humidity, and the GPS data that the IoT device is going to calculate. That information goes into the Provide blockchain in front of the smart contract. And last but not the least, we will do the Node.js code. We have used Google SDK to create a reader application, which is more using a browser mode. We have SDKs built in to do any mobile app. We have a Swift library to support it. We have a Python library and a Node.js library. Or you can also just use a simple REST API call to do that. Without further ado, let's jump into the demo and see how the code would work out. This is the particle device that shows how the Electron operates. The one that you see blinking is stating that the network is being established. We currently have a cellular connectivity using this is an antenna, cellular antenna that actually hardwires into the motherboard. This is the temperature sensor. As you can see, the temperature is it calculates both the temperature and humidity and transmits that data to the hardware. We have a battery. Current battery it's a 2000 milliamperes, so it could last about 3 to 4 days at about a 1 minute interval logging of the data. And all this is by default a POC given by the particles website Electron. We are not limited to this hardware, but you can always choose any hardware that you want. So this is the Solidity contract that we are talking about. The Solidity contract is designed, as we know, we use Solidity 24. It collects information like temperature, humidity, lat long, and accuracy. And this data is being stored according to the device. This contract is designed to have the data points. In addition to that, there is access control built in. All devices have a wallet concept. Every device would have an individual key that would be stored on Provide blockchain, so that you know exactly what devices you're working on. And we will also show how easy it is to create these wallets and store that in our system. In addition, I want to show you a little bit about how the sensor works. So in the sensor, which is called an industrial sensor INO code, the code actually goes and reads the data from the device, which is set at the calibration factor. The calibration is defined on the motherboard itself, and it gets these data points, which would be the cell reads it on a periodic basis using a loop factor, And once this data gets in, all the lat long and the temperature and humidity gets published onto the webhook. Once it's done, it goes in a loop. We also power it down so that you don't want to take up a lot of battery. And this number, the delay is configurable. Currently, we put it at 60 seconds, but we could also provision that data from the blockchain using the same Solidity contract. Now let's go ahead and see how easy it is to deploy it in our system. So I'm going to open a terminal that we currently have. Provide uses Provide CLI to deploy the smart contracts. Before we go into the CLI, first thing you would need to do is to create an account in Provide. So for that, you would go to don.provide.services. Currently, it's logged in as me. I can sign out. And you would, if you do not have an account, you can always go ahead and do a sign up. Otherwise, if you have an account, you can just sign in. Once you're signing in, you would come into the Provide network. We currently have two networks, which is a Unicorn testnet and a Handshake network. Let's go into the Unicorn testnet. You would go click on the icon to go into this. This is where the dApps are deployed. As you can see, all our dApps are in the dashboard, which would provide you every detail of how the applications are being defined, and also the nodes that they would be working it on. So let's go ahead and deploy our sensor code. So I have downloaded from the Provide documentation, I have downloaded the part of the Provide CLI. So Provide CLI is written in Go. You can either download the CLI and build it on your own, or you can just download the executable based on the operating system, whether it's a Mac, Linux, or a Unix, or a Windows box. We have executables that support different operating systems. So you just go to Provide bin. For me, I usually like to go ahead and build on my own because it's a good developer practice, right? Provide CLI, and then I would go networks, list public. So once you have done that, bear in mind you also need to authenticate the Provide CLI. So whatever account that you have created on Provide, you would actually do that. The system will actually automatically asks you for that information. Once you have done that, then you would go ahead and say create a dApp. As you know, everything in DLT are dApps, and you would create a dApp. Let's give it a name called IoT sensor test 2. I need to give it a network. And we will choose our Unicorn network. Boom, done. So once it's done, next step would be to go ahead and deploy our smart contract. So I would do go contracts deploy. Application would be the application that we just created. And then the wallet would be the wallet for how we want to do it. By default, Provide gives you a wallet so that you can use it right out of the box. And network would be our handy dandy unicorn network. Oh, I need to give the contract. Don't forget to give the name of the Solidity contract that you want to deploy. There you go. Once that is done, we need to provide it a token. We're going to use the wallet token that we have just created with. Done. Once that is done, you can always go back to the Provide dashboard, and you will see the IoT device that we just created. I have a lot of applications. What can I say? And you click the settings thing, and it comes up with your smart contracts. There you go. Whatever contract we just did, it's already into the dashboard, and now we can interact with it. There are API tokens that you select an API token, language that you want to do. As we were talking earlier on, you have Curl, Golang, Groovy, JavaScript, Python, Ruby, Swift. We have libraries to support all these languages. I'm going to use Curl. And the signing identity, the default one that we would actually be creating. And these are the methods. So ABI methods are the methods that our contract has actually created. So as we talked about in an earlier one, we use this contract, and here the contract is designed to do a recording of a device or add a device. So we would just simply do an add a device. 101 IoT test device 1, and as simple as that. And if for people who want to use Postman and you want to integrate that into your application, there is the code that supports it. This is in the curl base, how you would do it. Or if you want to change this to a different language, JavaScript promise, there you go. You can actually import Goldmine from the Provide.js. Provide.js is the JS library that we have. And then boom, there you go. All the information is right there. This would be your token, and this would be your wallet, and this is the contract and how you would interact with the contract. Once that is done, you would just go ahead and call the ABI. Boom, it's done. And let's go back, and we can see the transactions. As you can see, every transaction has been successful. In addition, you can also click on the icon and you'll see the block explorer. As with any blockchain, you want to make sure that it's in the block explorer. Provide Network supports the block explorer, and it also shows you the complete detail and data that goes along with it. Now let's go back to our IoT device and see how the data gets into this chain. For this, we have already created a device called IoT lease 1 in the contract, and this is a sensor device. So the sensor device will be automatically writing this data into the chain every 1 minute. In addition to that, Particle provided an ability to read through the data. So this is written in curl. Curl provides an ability to read the sensor data or the IoT data. If you click on it, if you run the curl application, it shows you. Again, you don't have to know all this information. It is there in a dashboard. It's an additional feature that Particle supports. You also can see all this data on Particle's dashboard. Let's go to Particle's dashboard. So Particle, as we know, is the dashboard that is the hardware provider in this case. In their console, we can see the devices that is being done, which is a temperature sensor POC. And these are all the data points that it actually does. And we created a webhook. We integrated with the Google Map, and we also created a webhook that supports this. As you can see, all the data points that are there, these are simple JSON data that gets recorded onto the Provide platform. And this is the web IDE that Particle supports. The same code that we just saw earlier on, the code that captures temperature, humidity, lat, long, and accuracy, and it gets published onto the smart contract. If you go to the smart contract, these are all the data points, and sensor device will actually use this ABI method called record data. And the ABI method is the record device data. So record device data shows you what the device is doing, the temperature, the humidity, the lat long. So this is not specific to just this particular device. Any device can call these data points and then send it onto the Provide network. In addition, let's also look at the code and how we have done this. So as we were talking earlier, this is a contract ID, the wallet ID, and the method name is the record device data that goes into the system. And we created a simple JavaScript that supports writing it into the Provide platform. And then finally, as we can see, the curl is showing out the current temperature. It is what, 75? That's pretty good. Humidity, lat long, current lat long that we have. And as we can see, every data point that is getting recorded onto the chain gives you a reference ID. So this reference ID shows that it successfully recorded this data onto the chain. And last but not the least, we have created a Node.js application that can go ahead and plot these data points using a Google SDK. So we did a Node.js, so it's an npm start. I'm running it on my local box. So it actually goes and reads the data points from the system, and there you go. It's a web browser. I can open up in a regular web browser and go to port 3000. There you go. All the data points are now read from the blockchain and plotted using Google SDK. As we can see, I've been driving around the town to get some data points so that you can visually see what all the data points are. In addition to that, you can click on it and it'll show you the temperature, the humidity, the time it got recorded, and the information that is associated with it. And we don't want to limit to this. You can also put geofencing, alerts, any additional features can be put on the reader application. Bear in mind, it would be easier to put that in on the reader than would be on a blockchain, because then you can control these parameters and tailor it to the applications that you are looking at. And that's it, folks. Thank you for your time, and I hope you have got some information about it. Please reach us out, and let me give it over to Stacy.
All right, guys, thanks again. This was a great demonstration. Thanks, Pad, for all of your work and development and building that out. I know we all thank you. If you guys have any additional questions, please just reach out to us at hello@provide.services, and hope you have a great day.